Okay, let's take a look at data storage and how can one store these data that we are generating, transmitting, and processing. So even before we go into more sophisticated data storage models, the most simplest way to store data is in files. I mean, one can imagine that a file can contain literally anything that you want to store in that, and that was how a lot of things were being stored. But then files have a very significant disadvantage because you can definitely store data, but the data is not really indexed. You cannot query or filter based on the contents of the file, and that's where sophisticated databases were developed in order to cater to specific needs of operations that can be done on a database. Now, database at a high level are two types. There is a relational database, there is a non-relational database. Relational database is where the entities or the logical constructs that you want to store have a very clear, very specified and structured relation in them. Non-relational is just the opposite of relational. So when you don't have that much structure or schema, then you would lean on to a non-relational database. Data lake is something that is a central consolidated way of storing data coming from various sources in its raw format. Then there are specific engines for storage, search, and analytics that are prevalent and very popular in modern data engineering or data science cases. And then there's an ORM, or the object relational model, which is how you actually interact with databases. So let's go deeper into each of them. So the first one is a relational database. Now, a database is an organized collection of structured information. And there are two really important things here: structure and organized. So when we look at the structure, the first diagram on the top left, as we can see, there are different records. So what this diagram shows is that it shows a database table that stores identifying details of individuals. So there's first name, there's last name, there's gender, and then there's date of birth. And every row in this table is a record. It's a record that goes in the database. Every column in this table is a field that contains specific information about a record. So this is, let's say, customer table as mentioned, and the leftmost column that you notice here is the ID column, and there is a small key symbol there. Now this key symbol specifies that this is the primary ID or the primary key on which there is an index, and if you have to search a particular record, you would search it as record ID 1, record ID 2, record ID 3. That's how the database knows it and understands it. And what is in the record ID 1? Then there's a field called first name which has a value John. There's a field called last name that has a value Lennon, and so on. So this is how a structured a relational database looks like. Now, when we talk about relations, there are really three kinds of relations that can happen between different tables. For example, there is a one-to-one relationship, there's one-to-many, and many-to-many relationship. So one-to-one is wherein one table is a record in one table is related to exactly one record in the other table, which you look at school and head teacher relationship. Every school will have one head teacher and vice versa. Every head teacher will be assigned to exactly one school. So this is where a one-to-one mapping comes into picture. Okay, now there is a one-to-many mapping, wherein, again, taking that school example, there could be many teachers that are associated with one school, but the reverse is not true. One teacher cannot be associated with many schools. So this is how you demonstrate one-to-many relationship. with a many part shown as a 3-prong, and the one with a straight line and a little bit of intersection perpendicular to that straight line. And then there's many to many relationship which can happen between the pupil and the lesson, because one student can enroll in many different lessons, and lessons can be enrolled by many lessons can be taken by one student, and one lesson can be taken by many students as well. So that's where the many to many relationship come into picture. Now these kind of relationships are the foundation of a relational database. Now there are additional concepts that applies into these relationships. For example, we just saw the primary ID. Okay, so now there is something called as a foreign key. So this primary ID or primary key is the unique key through which a record is known in a particular table. Now once you have to map this particular record to a different table, that is where the construct of a foreign key comes into picture. And that's how you can look at what are the relations that exists between different tables. For example, if we look at this third diagram, which contains the orders database, this is an entity relationship diagram. This is a kind of diagram that typically you would start off with when you are constructing a database, and this is where you sort of list down all the different entities that exist in your application. You list down the fields that each entity contains, and you list down the type of relationship that is there. So again, taking this example, there's a customers table that contains your customer ID, and this customer ID is going to be primary key for the customers table. There are other fields like customer name, contact address, and so on and so forth. Then there is an orders table, because a customer can place one or many order, which is why there is a one-to-many relationship between customer and orders table. If you look at the orders table, the order ID is the primary key for the orders table, and then there are other details, for example, customer ID, employee ID, and so on and so forth. Now the customer ID in this case is going to be a foreign key. What this means is that this customer ID will be referenced using the customers table in order to fetch the customer information. Similarly, there are, let's say, employees, and each employee has an employee ID, and again details like first name, last name, and so on. And these employees can also place an order, which is why there is a one-to-many relationship between the employees and the orders table. And as we can see, employee ID is also a foreign key. So if you look at, for instance, a single row in the orders table, it might look like, order ID 1, customer ID 30, employee ID 0 or not available or null, an order date as something, and ship order ID as something else. Now, Now this employee ID can be a nullable field, or it cannot be a nullable field. It really depends on how your application behaves. But if it is present, then it maps to the employees table. And similarly, we can look at the order details table, which contains further information about the order ID and the product that was ordered as a part of this order detail. So this diagram really gives a very clear understanding of how the different databases are modeled with each other. So you should probably pause this video here, take some time to go through it, and make sure that you have understood this ERD, because this is really how any relational database works. Like, depending on your application, it might get more complex or simpler, but the fundamental remains the same. Now, a database typically requires a comprehensive database software program, which is known as a database management system. Now, this DBMS or database management system, it serves as an interface between the database and its end users. And this DBMS allows users to retrieve, update, and manage the information that is organized, and it optimizes it to ensure that the database is actually performing in the most optimal manner that it has been configured. How do you query these data that is present in a relational database? And that querying is done using something called as a structured query language, or SQL for short. Now SQL, it's really simple. I mean, there are certain very basic and very easy to understand, pretty much English-like syntax that allows you to select a particular record from a table. It allows you to insert those records, update those records, or delete those records. And you can have nested queries which can perform many complex operations. So there are certain examples here. For example, there is the simplest structure for a select is select field names from table name, where filtering condition, and order by if required. And the example, as you can see, if we have to select all the customers that have placed an order, we can simply, okay, let's first select all the customers that have age greater than 18 years, so that they can place order for certain specific products that are available to be sold only to adults in their respective geographies. So you would typically go with select, let's say, customer ID, comma first name, comma last name from customer table, where date of birth is greater than 2002, and that will return a list of all the records that has date of birth greater than 2002. And similarly, if you want to, let's say, find out all the customers that have placed an order, you can perform a where clause, in which you have to look up in the orders table and the customers table and find out the customers that have placed an order. So I think that will be a good exercise for you to just try it out. Now SQL is a very common way of querying, and although it was natively developed for relational databases, practically you will find SQL in almost every data storage and retrieval system that you are using. They may not be exact SQL, because there are some very slight differences between the syntax of SQL queries depending on the database or the data storage system that you are interacting with. But pretty much all relational databases have some form of a SQL. There are some non-relational databases also that performs or lets you perform SQL-like queries on those non-relational databases. And then there are some non-relational data structures also that allow you to perform a SQL-like query on those data structures. So Pandas data frame, for example, it's simply a data structure that allows you to perform SQL-like queries on that particular data frame. Now, next we look at the non-relational database. Non-relational, like I mentioned earlier, it's simply the opposite of relational database. So, any database that is not as structured and does not contain the relations that are clearly defined in a relational database is a non-relational database. So taking this example, if you have to think of, let's say, a user that is adding comments or certain images in, let's say, a social networking website, you can think of posts as being a particular table. Posts as being a particular table, with ID being the primary key and title being the field of that particular post. And then there are multiple people who are commenting on this post. So comments will have its own table, and then there will be a relationship that will exist between posts and comments. Now again, in a non-relational context, you put all these things sort of together in a single row. So your post ID, the title of the post, and any comment, any images that correspond to that post goes in that same row. And this is really the biggest advantage of non-relational database, because it does not require a fixed schema. It doesn't require all the fields to be present. You can put arbitrary information, arbitrary schema in a non-relational database.